There we go. Okay, so where we are at this point, transformations recap version. So again, we've sort of like talked about everything. What we need to work on today is putting it all together and practicing with some stuff. So sort of big idea is that if I have some function, if I might make changes to the stuff inside, right? Changes to the input of the function. That's going to affect, ooh, is that an affect or effect? I don't know. Inside stuff affects the x values. So sort of we look at that as changing things from kind of a left, right, or horizontal perspective, right? So if you add or subtract something, it's going to shift to the left or right. If you change a sign, right, like a negative x, that's a reflection, but which way? If you looked at like f of negative x, right? So negative x on the inside of the thing, it's a reflection this way, right? Switching, left and right, so reflecting across the y-axis. If you multiply by, 2 on the inside, f of 2x or something, that's going to be a stretching, shrinking thing where we're sort of looking at it horizontally. Again, you're not really going to see any of that, but that's how it would work. On the other hand, if we change stuff on the outside, it affects things up and down. And again, I don't know if that's affect or effect. Doesn't matter. It's nothing with class. But so adding or subtracting shifts the thing up or down. A sign change, like a negative out in front of the whole thing, reflects it, but reflects it upside down. So reflects across the x-axis. Multiplying by a 2 or a half or something is going to be a stretching or shrinking thing, but again, from sort of a vertical perspective. Okay, so if we were to look at something like -3 x plus 1 squared minus 5. What can we say about what the graph of that function is going to look like? Start with what kind of a thing it is. What kind of a thing is it? Okay, so the parent function is x squared, so it's a parabola, right? Or a U-shaped graph, however you want to say that. But opening upward like that, sits on the origin until we start moving it around. What does let's just do things kind of one at a time from the inside out. What's plus 1 do? Shift it to the left. Okay. What else? Down 5 from the -5 here, right? What else happens? The other thing is that, right? That coefficient of -3 parked outside. What does that do? So is it going to look taller or skinnier or wider? Slimmer, right? Yeah, slimmer, taller, because you're multiplying by 3. Everything's 3 times on the outside. Everything's 3 times taller than it used to be. Well, it's going to make the whole thing sort of stretch out vertically, right? It's going to look taller. What about the negative sign? Flips it, how? Downward. Upside down, right? So it reflects it over the horizontal, the x-axis. reflects over the x-axis and stretches by a factor 3. Now, we got to think about a little bit about order, and again, we'll get into that some more today, but we have to be a little bit careful because we talked about this, I think, on Thursday, but if there's a if there's a y-axis right there, right? If I take a function and reflect it over the y-axis and then shift it to the right, it ends up over here. If I take a function and shift it to the right and then reflect over the y-axis, where does it end up? If this stays still and everything else flips over, it ends up over here. Okay, well, so it matters. It matters which order we do this in, right? Okay, so we got to be a little bit careful with that. So again, as you're kind of getting used to things and working with it, be thinking about the order that you do them in. That's why I listed them out in this order, right? I did the shift, then the reflection, then the shift down, and also be looking at a graph to make sure that it sort of matches up with what you think is going on. So I might graph this. Was it x plus 1? Minus 5? So you see, if we look at this as left and then reflect, right? So it flips it upside down and then down, we end up there. On the other hand, if I did the shift down first, or if I did the shift down first and then reflected, it would end up here, right? Okay, so we gotta be careful about that, watch out for that part, and make sure that sort of the way that we're describing things and what we think is happening from looking at the equation, make sure that that matches, what's actually going on, right? Okay, so I think we left off, sorry, anybody have any questions about anything at this point that you don't think, practicing and stuff would help figure out? Okay, all right, so last time, yeah.
The +1, that moves to the left one.
Yes, right, yeah, so the, stuff in shifts that happen sort of inside, or kind of a lot of things that happen is like almost feel like backwards, right? And again, kind of one way you can think of that is that think about the stuff that's in the input of the function, right? The stuff that's inside those parentheses or inside the square root or whatever. That's the thing that you're feeding into it. So sort of what you're doing is, if we think of that as like when things happen, this +1 means everything happens a little bit earlier. So it appears to sort of move to the left. Okay, so we left off last time. I told you to go home and practice the stuff on the back of the 2.3 notes. So let's pick up there. A lot of you are already in groups. That's great. The rest of you move so that you are. Compare notes on those, talk through stuff, ask questions when you have them. Start this again. Pretty more or less comfortable with what's going on here? I said, is everybody pretty much comfortable with what's going on here?
Yeah.
Is there anything we need to talk about? Okay. Well, I got some more stuff for you to do then. I know you're thinking, man, I wish I had some more math. I got just a thing. All right. Okay, so on the front, this is the thing I'm calling the front, there are some directions at the top, and then there are 4 functions with varying amounts of stuff going on. What I want you to do for each of these is kind of the same stuff that we've been working on, but start by describing the graph. So identify what kind of function it is, how it's been changed or transformed, be careful about the order. Of course, you're starting from the equation. So the very first thing you can do, and probably the very first thing you should do, is graph it, right? I mean, maybe look at it first, think about, what each piece means and how each piece changes things, but you can certainly graph that and, see and use that as a way to check. The back has a map of campus with a set of axes laid over it, with a grid on it. So once you have done all of that stuff, use the map of campus to sketch the graph. I brought a box of crayons, so feel free to use those, just give them back. Because I know trying to draw on a thing like that with pencil is going to be kind of hard to see what's going on. Then I want you so we've been talking about sort of like pick a graph up and move it around, like keeping track of things visually, right? So that point that used to be at the origin on the graph of the parent function, see where it ends up on your transform graph, and then tell me where that is on campus, and then write down the domain and range of the function. So the last part is again kind of a review, sort of tying it back to stuff we already know. Logan brought his own crayons. That's awesome. Or markers or something. Nice. Props. I like it. He's got his own markers. Sometimes, so I keep these in my desk, and sometimes I'm walking to class in a room that has like a blackboard. I'm like, oh, I gotta grab some chalk. I grab these out of my desk, and I get there, I'm like, this is not going to help me with the chalkboard. Maybe if I talk kindergarten or something, but crayons are awesome. And so anyway, there's that. You guys work together, ask questions, talk to each other. If your group is like stump, then, ask me a question or send a representative out for help from another group or something. Like, we're going to spend 20 minutes doing math. So let me know if there's stuff I can help you with. Yep. Yeah, if you want to actually draw the original thing or just, think. So with all of them, the point, all of the functions, the point that's at the origin kind of looks different than everything else, right? So what I'm asking with that third thing is just like, where is that point?
Oh, okay.
Okay. That's right. That one you do replace. up, so you think about, like, say the thing is if you were to go to the right line, right? If you want another point next to it, well, take like 4 over the bullshit, see what that is, right? Because you have the equation. That's the kind of thing people probably have to do line of homework to get like rid of. So, yeah, for the sake of like practice, I would go ahead and actually grab it. So plot that point, and then you just like so is that. That's so you're saying it's going right along the head. Okay, so then what I would do is like plug in 0. Because that's going to be in the that's going to be fairly easy to write in 0, and it's going to tell you where it is right next to it. Okay. So like when you go to do the stuff in the more graph stuff, that's where you like choose a graph, plot 2 points. Yeah, I mean, really, I would just do, sort of like something next to it, right next to it. So it's square root, so it's the right shape. What's this? No, no, it's on the inside, so it flips it, but relative to your y-axis. So you got this thing that shifted over here. And you hold this still, and flip it over. Where does that end up? Yeah. So what you did is basically take this and flip it this way, like where it was. But it's always the reflection that's really right to the y-axis. So, or the other way to look at it would be that if you're going to flip it in place where it is, and you got to shift like backwards. So I think that's harder to drag up. But the oldest still flip it over, it's actually going to, sort of end up over here. Okay. Yeah. Okay, so kind of ignore like everything else, right? You got like this, you're taking a thing and you're multiplying it by half. Right? Does that give you back something bigger than what you started with? Small. Okay, so because it's sort of sitting on the outside like that, we're talking about our y value. So all the y values are getting smaller. So is it going to look taller or all the y values get smaller? Is it going to go this way or this way? Shorter, right? Shorter, wider. Because you took all the y values that were where they are right now, and you cut them in half. Okay, y is up and down, so it all looks short, right? So when I say that it's shrinking vertically, I mean it's the graph is sort of flattening out, or looks wider and shorter. There's a bunch of different ways to say that, and they can all be kind of misinterpreted in English is precise, right? So yeah, that's what's in there.
So it's like half, for example, all that.
Yeah, think of it as like the x stays where it is, and the y is half as tall. So it's going to look short. If there's a 5 instead, think about the x stays where it is, but the y is 5 times bigger, so it's going to get taller. So you can keep track of the 1 point that is, it's an absolute value, so that quarter point, right? You can track it out, like you can get 0.00. point, this would be the graphic thing. To get another point, I would just take an X value like next to that, and take an X value that's in it, so like plug it into the function and see what you get, and then like plot that. Okay? You guys are okay? Right up. You guys all right? Okay. Yes. Why? Right, because so y-axis, right? It's over here when you move to the right, but then you hold this still, so when you do the reflection, it's like the whole thing's sort of scooped around. And it's up. Yeah. Yeah, I think if you like literally think about it as, I'm gonna like hold my paper still and set the y-axis down where it was to begin with, but I'm gonna flip it over, right? And you see kind of what happens. Okay, well, it's over here. I think that was flipped over. It's gonna be over there. Yep. Everything else is fine. Okay, it's just for first thing. So that part's good, okay? I'll just use that. You guys done? Where'd you end up? For which one? Let's go in order. Run number one. Huh? Okay. Okay, all right, so go back and look at it, figure out what it is about that that doesn't someone. Okay, yeah, that one you gotta be careful with the shift. So where you probably caught on to this, but the places that you really have to be careful about that order is when you're sort of shifting and reflecting in the same way. Like if you're shifting to the right, moving over the y-axis, that's where you really have to be careful. Right? It's not as big a deal if you like shift that way and flip it upside down. That part's fine. It's when you shift it and then reflect the same way.
Oh, we're on the map.
Okay, let's talk about that. So that's number three, right? Okay, so what happens in number three? It shifts to the right four and it reflects. Right, which means it's gonna go back. Okay. Right now. And then you reflect. So the last one's the best one. So square x shifting to the right. Right. Y-axis still flip it over. It happens, it happens. Swing, change direction this way. That's also good. Was it four? But the whole Y-axis still flipped over. So you take the opposite. This way sense. What's happening to me is that, so, yeah, you said it right, it reflects over the y-axis. The y-axis. This way. So that stays still. It's basically like a paper right now, right? Down, down, down. Oh, yeah, because you just give it a number, the answer's gonna be close. Right, so if you type in like, you know, yeah, yeah. Before you start moving, right? So take the square root function, move it, reflect it, now it moves over. Right, so that changes what it means to be positive. If, say, it's like look at this, because of all the other stuff going on, you get nothing happening underneath that square root is positive, and then it's okay. Yeah, so it's because of all the other stuff that's happening. Is it okay? Yeah. Okay, so just kind of real quick version, see if we're all on the same page. If you're not, then go home and try to figure it out or ask questions, come to office hours. First one looks something like that. So that's shifted to the left and down. Second one looks like this, shifted to the right and down and stretched. So that's actually taller than x squared. Third one, this one is tricky, and I talked to a lot of you individually about this because you're shifting and reflecting in kind of the same direction. That's where we have to be especially careful about the order stuff. Looking at this, it's a square root function. The -4 shifts it to the right. The negative in front of the x says take the opposite in terms of the left-right sort of values. So what that does is reflect over the y-axis. So you shift to the right, then you reflect over the y-axis. This is the part where we got to be a little bit careful. What happens to this thing, the graph, is that the whole thing sort of swings out and around and ends up over here. So at -4 and then sort of pointing toward the left, right? Because again, you took this square root function, moved it over here, and then flip it over, the whole thing flips over sort of with it, right? So it ends up over there, the opposite of 4 if you want, and pointing in the opposite direction. The last one has kind of everything happening all at once. Absolute value, 6 to the right, -1/2 out in the front. So it's going to be upside down and taller or skinnier or wider / shorter. multiplying by half, so it's gonna be like wider or shorter, right? And then up 5. So it's something like right there. Those should put you at, if you do all of that, Ashby football field, science building, and the pitcher's mound on the baseball field. I put that grid over that, and I just couldn't pass up the fact that the pitcher's mound was like right on the point. Perfect. So that's where those end up, and then, you know, figure out domain and range stuff as well. Okay, so tonight, I would suggest that you go do as much homework as you can. We've done everything. All we're doing at this point is sort of putting it all together and making sure we know how everything fits. So I would go do some homework. If there's anything here that you're, you know, what you did disagrees with what I did or whatever, then try to figure that out as well. We'll pick up there tomorrow. Again, tomorrow, I'll have a quiz for you, and we'll spend the rest of our time just kind of, you know, doing whatever else we need to do to make sure we're good to go with everything from the last couple of weeks. Okay? All right, y'all have a good day. I'll see you tomorrow.